All right, let's keep doing a few more problems from the washer method. So this is particular one, again, I got it from an old textbook. So we have our first function, 6 minus 2x minus x squared, which is this red parabola that's on your screen. And then x plus 6 is the blue line that's on your screen. And we're going to revolve it around the x-axis. So that's what we get. We get this kind of shell going around. There's a pretty big gaping hole going on here. So when I draw my radii, my big radius is going to go from the x-axis all the way out to the top of this. And then my small radius is going to go from the x-axis until we get to that blue line. We are going around a horizontal axis, so everything should be in terms of x. To find your boundaries, to find the smallest x value and the biggest x value, you may, if you're using a calculator, be able to just find them that way. If not, you would need to set them equal to each other. So I know I have that work somewhere. Here it is. So set these two functions equal to each other and solve for x. You get 0 and -3. So -3 is this point here, and then x equals 0 is this point. Big radius, again, is my parabola. Small radius is my line. So I'm going to set it up from -3 to 0. Put it in your calculator. Obviously, there's going to be tons of parentheses that we need to mark. Make sure we have in our calculator, and then let the calculator do the work. And you get 243 pi over 5. Exact same function, but this time we're revolving around a different line. So we still have the parabola and we still have the line, but now I'm revolving it around the horizontal line y equals 3, which is in green on this picture. This one's one of my favorite graphs to do because it looks like Pac-Man. So we are finding the volume of Pac-Man. So as I draw this, my big radius is going to go from the y equals 3 line out to the top of that graph, which is the parabola. And then my small radius is going to go from that y equals 3 to the blue line. To find these lengths, I'm going to do top minus bottom. So it's going to be the parabola minus 3 and then the line minus 3. My boundaries don't change. They are still -3 and 0 because we didn't change anything as far as what variable we're working with. We're still working in terms of x's. So I've got big radius is the parabola minus 3, which you can clean up and subtract the 6 minus 3. Small radius, same thing, line minus 3. Boundaries do not change, -3 to 0. Big radius squared minus small radius squared, and we get 108 pi over 5. So that is the volume of Pac-Man. And then I've got one last one here. So this is 16 minus 4x, which is a line. It is in red here. And then 16 minus x squared, which is just a parabola shifted up 16 spaces, which is written in blue. And we're going to revolve it around the x-axis. So this is super, super skinny Pac-Man heading the opposite direction. So my big radius is going to go from the x-axis up to the parabola. And then my small radius is going to go from my x-axis to my line. Big radius squared minus small radius squared. My boundaries are going to be the x that it starts at and the x that it finishes. You can probably tell just from the graph that it's starting at 0 and ending at 1, 2, 3, 4. But if not, you can always set them equal to each other by doing this. So my big radius, my small radius, my setup from 0 to 4 integrated, big radius squared minus small radius squared to get a skinny Pac-Man volume of 1024 pi over 5. So those are some more examples of how the washer method works. It is easiest done in terms of x's going around a horizontal axis, and it's usually most commonly done around the x-axis, although we did see ones that we can work in terms of y's.